Hi, Rick. Thanks for joining in today's podcast. We're happy to have you in our show. And on today's topic about AI in manufacturing, I'd like to. I see that your profile meets most of the check boxes. Like you have a great experience in manufacturing from the old days till now. You have worked on various technologies. I'd like to make yourself given brief introduction to our audience, and we'll go from there.
Great. Well, I'm glad to be on, and thanks for inviting me. Always fun to talk about how manufacturing is about to change or actually has started to change. So, I've actually had a pretty long experience in manufacturing. If you go back to the beginning, I was a young engineer in manufacturing at what's now Honeywell, the
Okay.
Autolite spark plug plant. Making a million spark plugs a day. Just
Mhm.
really hardcore manufacturing. And I really was very involved in the early automation of making everything robots and so forth. But I also got very involved in IT really early on,
Mhm.
probably before all of you on the podcast were born.
Okay.
No, I mean, probably really.
Yeah.
And
Okay.
that actually, career wise, gave me, it's hard to come out of a dirty old spark plug plant in Fostoria, Ohio, and
Mhm.
uh, get anywhere. And but I knew about IT, and it turned out there was a large project there between Bendix at the time, or really Allied Signal, and IBM and Accenture to really create the next generation of shop floor. And I was the program manager.
Mhm.
And I just got very knowledgeable about what was coming, and that actually helped push my career into being a CIO in an electronics company, probably when there weren't CIOs. I was one of the first, and then at Cummins Engine, and then various startups in that e-commerce time, and ultimately ran all the IT of General Motors. I was not the CIO, but I had
Mhm.
operations and so forth. So a lot of IT experience. Then I said, heck with this IT stuff. It's too hard. You either get fired or you get promoted, and it's hard on the family. So I went back to engineering, and I became head of engineering operations at a company called Johnson Controls, which
Okay.
ultimately was the largest auto supplier in the world. And I had sort of most of the creation of things, all of the testing and just everything. And I did that for about 8 years, then went to a company called Dassault Systems, which is the largest PLM and CAD company. And I was in charge of the North American auto industry for about 8 years. Then,
Okay.
when IT or AI came along, and this is probably why you have me on the call here, uh, one of our largest, actually, North American service providers was called Infosys.
Mhm.
And I like the people there. In fact, I was the first engineering customer of Infosys when I was at Johnson Controls. So I knew
Okay.
them from the beginning. Good people. And I went to work for them, primarily focused on generative AI for manufacturing for about 2 years. And the early phase of that, Infosys had been one of the first five investors in OpenAI and
Mhm.
had a really lot of capability. I met Jensen as part of that because we were going to certify, I don't know, I think 70,000, 50,000 people for him. But
Okay.
I worked with about 70 different manufacturers, a lot of it in manufacturing, more than uh, product development, but both. But after about a year of it, I realized that how should I say it, the startups actually had the advantage. All the little startups that were doing AI as compared to the service providers or even the big PLM companies. And was working with all of them. So I now represent, or I'm sort of on their advisory board of a bunch of Silicon Valley generative AI startups working on manufacturing. So there's a whole background, but it's pretty, I guess, relevant to
Yeah.
probably what we're going to talk about today.
Yeah. It is pretty big, large. So what sparked your interest? Why you been with various roles? You were with the CAD, and suddenly why you went with AI? What sparked your interest?
Went with what now?
What sparked your interest? Why you went with AI? Like why you went
Oh,
with
well,
Infosys?
because so I probably was one of the person that helped create the concept of PLM. I actually,
Mhm.
with my teams at way back in Allied Signal, wrote one of the first ones. Even helped develop Oracle applications back in that time. And so I've been involved with the process of it for a long time. And I would say, I mean, certainly there's been some advantage, but in the end, capturing all the data added some value, but it also added a lot of overhead to the engineering teams. And I had hundreds, thousands of early engineers that would always come back to me when I would go to the next best PLM and tell me, you've just doubled my work, typing
Okay.
in numbers and so forth. And when I saw the when I saw what generative AI, not machine learning, but generative
Mhm.
AI can really do, it actually was the first thing that really attacked. Well, if you think about what PLM does today, an
Mhm.
engineer in his head,
Mhm.
he goes and tries to understand everything and he types it into a system. Okay.
Okay.
And it's in the system, so some other engineer off somewhere else can find it and, go back and forth.
Mhm.
But it really doesn't help the engineer's head. He's working to feed this system to feed something else.
Okay.
And we do have reports, but few people look at them. And
Okay.
so the generative AI was the first thing to really help take the workload off of the engineer's head so
Yeah.
that he has to think less. Now, I think we've all experienced that. I assume everybody on the call has used the AI in some form. And
Mhm.
probably more and more, everything we do today, we first check with AI to make sure what we're doing is okay. Well, that's a big deal when you have these massive sets of data, incomplete data,
Mhm.
et cetera, to just quantify it and give a sense, at least a starting point of where things should happen. And it's the most, well, I've seen a lot of stuff. There's nothing like this. Now, I know there are true believers and people that say, it's never going to do anything. It's a big, big deal. We're just learning how to use it. And to be honest, I'm old enough and experienced enough and even financially set enough. I don't need to do this, but I'm
Mhm.
not going to miss this. I mean, it's like missing the coolest thing that ever came along, at least from
Yeah.
what I can tell.
So, how do you see this wave, this generative AI wave, compared to the previous technology shifts in manufacturing, like all these automations?
Well,
This.
certainly.
Mhm.
Well, okay, going back to the early manufacturing, we have some machines and we have people that run them and we have people that inspect things and a lot of
Mhm.
people. So when you're doing a million spark plugs a day and all the parts, it's a lot of people handling stuff. Now, in my time, we did, I think it was called SIM, computer integrated manufacturing. What that really meant was we would put in robots, which if I think back to that Autolite spark plug plant, it probably replaced, I don't know, 500 people picking up spark plugs, looking at them and setting them on the next tray, the robots we put in. And if you look at manufacturing today, those robotics made a huge impact to the actual physically handling and doing things. But we actually increased pretty significantly the amount of knowledge work or thinking or reports or analyzing, et cetera, that had to be done. And I think in this case, AI, generative AI, is exactly attacking that. It's taking the overhead that we put in during my time, and we're also probably improving pretty drastically how things can work. I remember when we put in an early, well, Allied Signal in my time was also a big defense contractor, and
Okay.
we actually were doing AI maintenance systems for attack helicopters back in my time. And there
Mhm.
was a thing called Prologue and Lisp, and we actually brought them into my plan, and we spent all this money and whatever. And it didn't really work. I mean, it was fun to do, but so for a long time we've been going after this issue of how can we help workers on the night shift, for example, know what to do when something goes wrong.
Mhm.
And I mean, this is a big deal. I don't know if that answered your question, but
Mhm. No, I understand. So, is this, in your opinion, this is going to be the biggest change, or is it
yeah, you're
is
asking how does it compare?
to
Well,
previous
it,
shifts?
it's not going to. Well, in product development, it's a bigger deal than it is in manufacturing.
Okay.
Just if so, what you need to look at is the areas where people spend time. Okay,
Hmm.
that's number one, and then secondly, areas where lack of doing the right thing immediately, the timing issue is a
Hmm.
problem. So things that aren't done quickly enough, meaning almost immediately, or things that generate manpower. And so up in product development, there's more of that than there is in manufacturing on the one hand.
Okay.
On the other hand, in manufacture, I mean, product development's probably what, anywhere from, depending on the company, 2 to 5 to 15% of the total cost. Manufacturing is where the cost is. And if we're talking pure manufacturing, I wasn't sure about, whether it's
Mhm. Yes.
manufacturing or product development, but for this call. But if you're talking manufacturing, a little mistake, a little lack of action, at least at the right time, can generate huge amounts of cost. And also, during a lot of automotive companies, anyway, really their profitability at a deep level is based on how they do with their the startups of their plants. The changeover of the new models. I remember when I was at GM, and we would be doing, I don't know, I don't want to exaggerate it, but 300 of them in a year, and it really came down to 80-90% of them went smooth, but 10% of them really had big issues. That would literally define the profitability of the company, those mistakes. And so, not making those mistakes, doing things on time or preferably quicker in manufacturing is really where it'll show at the bottom line, but also it'll make life better. And
Okay.
one of the startups I work with points out that if you try to talk to a manufacturing guy, he doesn't have time to talk to you. There's always something he's got to run and do, take care of, and I experienced that in my own life. And with the generative tools, they can literally look at the real time data, see
Hmm.
what's wrong, diagnose it, and now this is a subtlety, and give very detailed advice for somebody to go fix something.
Hmm.
But that's the answer to your question, and I want to
Okay.
continue
I
with more
understand.
of a thought on that.
So even on the product life cycle, that would be my next question. Can you explain like how it is transforming the product design and engineering? Like, is it? I know it is 15% of what the company spend. So how is it getting automated? Like, what kind of
Well,
value they're
if
seeing?
we go to PLM and
Mm-hmm.
well, it's really, if you think about that flow,
Mm-hmm.
there's the requirements management, so you figure out what you want to do.
Mm-hmm.
There's the sort of early industrial design, and the conceptual part of it. There's the detailed design. There's the simulation, and then there's the testing, and then the creation of the tooling and so forth, and the startup. It's pretty much what it is.
Mm-hmm.
Well, every one of those has great opportunity for generative AI in the requirements area, especially because, well, for a seat or an interiors, a seat especially, you get about 200 requirements from the OEM,
Oh.
and you need to really blow those out into, like, I don't know, several thousand detailed requirements that
Mm-hmm.
you try to manage. And of course, it's different from every OEM. And we used to make about a third of the auto seats and design in the world, and so we had that process for every OEM, and you never get it quite right. But
Mm-hmm.
so that's the start point. AI can really help make that better. And even there's a concept of called MBSE or SysML, which is used more in defense and aerospace, and Ford uses it and a few others, but it's hard to do in automotive just because, well, we
Mm-hmm.
don't have as much money or time as the aerospace people do, and it's too complex. Well, Gen AI, they're starting to put that in there. That can really help that. And that's really requirements as a model. So let's assume that we get to that. Then that really pushes down into the CAD space. Now, for a quick for looking at everything that's been done prior, your whole history of parts, don't make one you've already done, or take often what we did was often in automotive the parts are custom, at least a lot of them. But a lot of the cases, the connections between parts are standardized. So and it's hard to figure that out. Like, in other words, I want to make this, but I don't really have one of those. But is there something that's done the same connections that I can pull together? A lot of thinking, a lot of experience. It's
Mhm.
where the really old, I'd hate to say old, but very experienced design engineers make their money. They can say, we did something like this before and it didn't work, but so don't copy that, copy this one. Well, AI can look at that. I think in my life at Johnson Controls, we had about over 7 million assemblies, or at least parts, I guess. And then probably, I don't know, 10% of that is assemblies. So we would go to an engineer, we want to do this new thing for Ford or GM, but use something we've done before. Now, how many people can sort through 7 million things? I mean, you can't. And so
Mhm.
they generally either don't or they pull just one they find. And I think in my time, an engineer typically, when they were looking for a part, spent 2 hours in the system trying to find it before they either found it or gave up. Well, that
Exactly.
shouldn't happen anymore. I mean, the AI should bring that to the forefront. And I'm just walking through the process. Now, during the detailed design, now this is a subtlety.
Mhm.
Generative AI actually does not work very well with CAD. In other
Okay.
words, it's almost a I'll come up with some word, but they just are different things. What CAD is very exact, and they, depending on the CAD system, they used very different mathematics, but it's very precise mathematics. You don't want a Boeing plane that got it almost right on the tolerance. I mean, literally. Now, if
Yeah.
you think about what Gen AI is, it's the opposite of that. It's a statistical tool that will give you something that, in many cases, is very close to being right. But I once had this, I got it wrong, actually. I was talking to the head of research at Michigan State, and I said, CAD is always, or Gen AI is always wrong. It's always pretty much close but wrong. He said, no, you got it wrong. Generative AI is almost always right. So is it almost always wrong or always right? And he said, and it's generally more almost always right than you are, Rick. And I think that's showing up. However, it's still not right. So this concept of agentic AI, where it'll automatically go, and if you think of CAD, and automatically create your CAD design and put it together, uh, it's probably it's not going to work. And I've talked to an expert on this who had a PhD in from Toronto in
Mhm.
geometric something, and they're trying to do some things with it, but really it's more bringing to the engineer something that's close and getting them all ready to put it together and then run the detailed testing and analysis and et cetera. So that's the CAD part. Now, over in simulation, there's a huge opportunity because
It's kind
right
of digital
now,
twin on like
what's
something like digital twin.
well, digital twins, yes, I guess
Yeah.
there's a lot of ways to look at what you call it. There used to be a thing called model build, which
Okay.
was really, I guess, digital twin and model build. Maybe it's me not knowing what people have defined one or the other, but in essence, the concept would be that you can actually, I guess, digital twin the product, and then you can analyze it, and it'll, maybe even analyze it in the environment that it's going to run, and then you can get the results. Well, we're far. We've in my past, especially at the SO, we really have worked on that and made some good progress. However, in that world, you want things to be exactly right, and they never are, even with simulation today. But the real problem is this: if you're an engineer and you put two parts together, you make an assembly, and they pretty much, and then you keep building more and more parts to it.
Mhm.
Then you say to the simulation guy at a certain point, go and do a simulation and tell me how this is going to work. And they go off and do it. In today's simulation tools, even up on the cloud, if it's a big thing, it might take a day, it might take 2 days. And that's when they do it. They still have to mesh it, and it often can go to weeks, month, whatever. Now, during all that time when you're waiting on the simulation, the engineer is putting more and more parts together. And by the time this, and I fought this for years with my teams, when the simulation comes back, they said, well, that's not relevant anymore. I've already changed it. Okay. And so, I don't want to spend and money. It costs a lot of money. I don't want to spend all that money now. Now, where that really comes to play is when the design's done, and in a seat's case, it's at the sled test because we would always design right at the limits to keep the weight down. And so, in most cases, especially during DV, it fails. And then you really got to look at the simulation because you have this huge thing,
Mhm.
hundreds of parts that are put together in a certain manner, and they don't work. And so you use simulation to figure out how we're going to patch it. You can't really go back and redo it all because it took you months, even a year to put it together. So that's the engineering process today in most automotive things. You get it all near the end, and then you use simulation to tune it. And then you say, well, next time we'll know better than, but then you forget about next time because years pass. Well, what I think, I'm not 100% current on this anymore because I've been away from it almost a year, directly on with the simulation vendors, but I was very involved at Infosys with it. And if you take Ansys and now Dassault and I think even the one Siemens bought, in any case, they all have they have machine learning in there now, not necessarily generative AI, but they've spent a lot of money and years in machine learning. And I think at least Ansys is the one I looked at as a partner in the deepest. And if you do the one big run for 2 months or something on a generally a pretty large assembly, maybe even a whole vehicle,
Mhm.
then you can, next time you want to tweak it, you want to change an antenna or change the design in some manner, or machine learning would give you almost immediately a feedback to say, if here's in a high 90% probability what your change is going to do. Well, that's always been my dream, that the engineer, if I put two parts together, or maybe more than two parts, but something that has some physical result, I can say, now AI, tell me if that works. If you think about how we write software today, which is something I do every day,
Mhm.
ideally, if you're doing it perfectly, you put a line of code in, and then you say, "Does that work?
Yes.
What work with the rest of the thing?" And it comes back and says, "Now you have a comma missing, or no, that's screwed up something else." And you say, "Oh, I'll fix it." And then you work through the whole design in that fashion. It's the most efficient way, actually, because you don't have to find bugs. You just your line you put in, and it's right or it's wrong. Well, if you can get that back to how mechanical engineering works, I'm sorry,
Yes.
if you can get back to how mechanical engineering works in a similar manner, where you do something, you see the effect, you do, that will just massively improve the products and et cetera. And people understand that. And when I was at Infosys, every customer asked for that. Now, so that's happening, and the Gen AI will just move that further along because simulation in those early phases is not exact even today. It's
Mhm.
approximate. And so Gen AI really will increase that capability. Now you move on to where you have, you're going to make parts, right? And you get parts back. That whole concept of developing test requirements, which AI is fabulous with,
Mhm.
not perfect, but probably better than a human. A human still needs to look at it, and then analyzing test results also. And that's even in medical today, that's heavily out there. When you get a scan, as they call it, or an x ray, uh,
Mhm.
somebody used to read it. Now they read it with the AI, and then it finds things. Not actually, the human finds things that the AI didn't, but the AI finds things that humans haven't. And I think in some respects, medical already understands what the future is going to be more because they understand that it's not perfect, but it helps. And then, of course, as you go out into manufacturing and all that mess of information and finding out what didn't work. Anyway, a long answer, but a lot of opportunity. And I think primarily in manufacturing, it will be some reduction in the cost, but mainly it'll just affect the cycle time, in getting
The
products
speed.
out.
It will
And
speed.
it's almost linear, other than the prototyping tooling. How long it runs almost defines the cost it's going to be. So I've thought that it's somewhere between I don't know, I say a 20 to 50% opportunity in product development, and probably more like a 10 to 20% opportunity in cost savings in manufacturing.
Hmm. So, why do you think for a manufacturer, like the best use case that they can see and value with Gen AI? Is it going to be on the design or predictive maintenance or supply chain planning, digital twins?
Well,
Where
I
do you
think
think?
it'll be in all of them, but
Mhm. But they
uh,
cannot invest in all, right? They will just need to prioritize something to do it, right?
well, manufacturing. I've pushed this to a bunch of really big time manufacturing
Hmm.
people, like the experts, and one of them said to me in a nice way, he said,
Hmm.
when a manufacturing plant has things working, they don't like to touch it. In other words, they've been had so much experience with people like me bringing in, this is going to be wonderful. It's going to change your life. Well, it does, but
Hmm.
typically not to the good. and,
Okay.
and maybe it does to the good, but generally years later. And I've had that experience myself.
Mhm.
But actually, a funny story. One time back in my spark plug day, we put in early, robots and computer stuff. And this one guy that ran the big plant, manufacturing guys are powerful inside their plant, the manufacturing manager. And he hated this stuff, but he was being forced to do it. And he bitched about it. And, anything we did wasn't good enough. And he was just really a drag on the project. And I had this one guy, that was really working pretty close to it on the shop floor and with him, and my guy hated the guy. I mean, just they didn't get along, whatever. And then when it started to work a year or so later, the manufacturing guy then would talk to people about how wonderful it was, and like he had done it all himself. And my guy came back to me and said, how can this guy do this? He's fought us all the way, and now he's taken all the credit, and he forget we had anything to do with it. And I said, that's the greatest compliment somebody can ever give you. They don't even remember that you did this. They just have accepted your sort of new way. Well, I think that's probably how it's going to go with AI in manufacturing. It's
Definitely.
I've seen a lot of well, actually, there's another problem going on in manufacturing,
Hmm.
and it's probably one of the reasons I left Infosys to go with these startups. Um,
Hmm.
AI on a lot of things can make a big difference. In other words, and and of course, manufacturing engineers and the people that support them really have worked years and years to try to make things better, and they have. But a lot of times, they've never had a tool as powerful as this. So almost every manufacturing situation has skunk works, or maybe even small funded skunk works, where the manufacturing engineers, the computer team, or whatever, they're doing their own welding inspection, they're doing their own uh, something in testing, they're doing something, a new tool they've developed in software, and they're mainly trying to do it with the open tools like Anthropic or OpenAI or the Google stuff, and and some of them are funding them internally pretty heavily, a lot of internal funding. The problem with that is there's a lot of outside things, whether it be the big software vendors that are coming in with they aren't there yet, but whether it's the Dassault, Siemens, PTC, they're heavily in a war to try to get this stuff into their products, and they're starting to. And but they're charging a huge amount of money for those tools because it's a new revenue stream, but that'll commoditize over time. But what I'm seeing is a lot of resistance to those tools, and even resistance to some of the Silicon Valley guys' tools that I'm dealing with, because we can just do that ourselves. Well, let me give you an example. I work with one called Arch Systems, which is
Okay.
dominant in semiconductors,
Hmm.
and they go in and they collect the real-time data off even the old machines, off the screens or the old machines and whatever. They take all your maintenance data. They do the big plant-wide things we've seen
Research.
for years, but more importantly, they use the cloud AI, Anthropic really, to immediately diagnose what's going on to the machine, actually give you like four options, the main one, the next one, the next one, and dispatch the maintenance guy on any shift to go out immediately and try to fix it. Now, the old model would be you wait for the experts to figure it out, and a day or two later, or even hours later. And so, and they've spent, I don't know, tens of millions of dollars to develop that capability and keep it running. So
Yeah.
what I've realized was even though if I was one of those engineers or manufacturing teams, I would be doing what they are. I would be personally getting into this. It's fun. It's I'm going to change the world. I'm buying these tools. This is and you're making a difference. But compared to the difference that I've seen of these people that have done it at scale, it's something that can be maintained. It would almost be like the guys on the shop floor are going to write their own PLM system, which I did years ago. The problem with that was who's going to maintain that? How are you going to keep it current and whatever? And so I think the biggest, and maybe I'm wrong, but what I've seen is the biggest problem in manufacturing right now to do it at scale where it's going to affect the top line of or the full top line of the plant is there's so much of that, let's say, focus of the people that ought to be figuring out what's in the market and figuring out like 3 years out, how are we going to have this running everywhere? And they're doing these little pilots, what do you call them? Proof of concepts. And I think that's good to learn about it. But unless that company is going to productize that type of thing for themselves, they're really on the wrong path. Anyway, I wanted to throw that out there because it's a
Yeah, and
frustration.
I totally understand that. So, AI, like in my opinion, it is connecting, helping on the design, engineering, on the manufacturing, and the supply chain. Is it correct? That's how
Yeah,
it,
all the
AI.
data can be looked at holistically with a cause and effect, but it's not perfect. Just always remember that. And there's another problem that
Mhm.
in manufacturing, and I've just really been studying this recently, and that's the issue of how do you test that this is really works.
Yeah.
The more you go toward which is the push right now, you more you go toward to using AI to actually take action, agenic, as compared to just give advice and simplify the work. Um, there's there's a whole new sort of discussion on. Well, see, the problem with AI is if I write something as an engineer, like if this, then this,
Okay.
okay, so everything works, right? If I see this, then do this. That's pretty succinct. I mean, if it's wrong, it's because I got if then and rather than if then this, it should be if this and this then. I forgot a few thises. Well, that's not how AI works. AI can be different every time, even on the same data. And so, because it's the statistics that's never quite the same. And you can see that if you ask it to write your resume and then ask you to write it again and again, it'll always be somewhat different. Well, that's really, really dangerous on the shop floor if it actually takes action. So, it could be very valuable if it didn't get it right the first time and you ask it again and then it'll come up with a better answer. So, figuring out in manufacturing how to keep that within a bounds of what. Well, okay, there's a study out recently, and this ought to scare a manufacturing person. It scared me because I'm not going to say that I might not have thought about this before, but in some of the things I've done. But
Mhm.
somebody took and gave AI options. It said, here's the good ones and here's the bad ones. Okay, in other words, you AI need, here's your problem and here's the options you can take even when you didn't, they call it put it under pressure, like you got to get it done now. I don't know, the machine is heating up. That puts
Mhm.
pressure on it, and they put pressure on it. Even without pressure, about 14% of the time, it picked the bad answer.
Okay.
That's not what, in other words, I don't know, I'm not going to say bad things, but it could be catastrophic.
Catastrophic.
And if you put it under pressure, it went up to 80% of the time. If it couldn't fix it with the good options, because it's the concept you try one thing and another, it started picking the options that had clearly been tagged, don't do this.
Okay.
And that's not something that, I mean, I'm sure people are working on that problem, But if you think about that in manufacturing, that's a sort of a big deal. I don't think it's as big of a deal as if you're on a help desk or something and you're saying, try this. Okay, well,
Yeah.
if I tell somebody to try this, it's probably just as likely to be not right as maybe less, as a guy from Michigan State said. What I come up with is probably less likely to be right than what the AI will do. But when it's taking deterministic action on something that you really can't have it do wrong. Now, as a controls engineer, I've thought about this, and I certainly would put another level of control around it. Just a framework where it just can't do the bad thing. But anyway, I thought that was very interesting.
For the, so the other question is more on the integrations. Like manufacturers generally have that kind of so many systems that are not connected. Do you think AI can make this integrations by any means, or because data is what AI can thrive on? If the systems are not connected, how
Well, yeah,
would
and,
this?
and actually, the company I've been working with
Mhm.
goes after that. Yeah, I mean,
So
we've
you
worked.
guys work on that completely on those
Well, they
integrations.
they do. I just help people understand it. Well, yeah, and at Infosys we had a thing really good called Smart Factory. I think everybody names it something, and I think they were doing Toyota and some big deals. And the concept is you collect everything, you put it into a data warehouse, you use it all across. That's a great idea. And certainly if you build a new plant, you should have that. And maybe even on your old stuff. And first of all, if you can put it together in a structured manner, that's really good.
Hmm.
But if you look at what information you really need to use in manufacturing, it's not all off of the machines. It's on spreadsheets, it's on emails, it's on information coming in from the supply chain. It's it's coming in from everywhere. And what you generally do is you rely on a human today to sort of piece all that together and make a decision and take action. Well, AI can just really nail that, because if the data is structured, it's better, it's the best. But most of our data is unstructured. Here's an example of how bad the data is in manufacturing. One time during a startup this is some years ago, but I doubt if it's changed. We had out in Valencia, Spain, a startup of, I think it had everything, interiors and the whole bit, a big Ford program. And there were a lot of mistakes made. And I think I personally had 300 people out at the site, okay, working, and maybe that many back in Detroit. And I had what one of the groups I had was called Six Sigma, and the Six Sigma engineering and the Six Sigma manufacturing reported to another guy. Anyway, we said, okay, this is such an interesting situation, and this is going on for a while, and there had to be some redesign. We found there were about 300 spreadsheets in use. Every person had their spreadsheet or a copy of spreadsheet or whatever. So over about a 3-month period, we had the Six Sigma people collect all these spreadsheets every day and do some kind of an analytic analysis on them. Well, it turned out that only 50% of the information on those spreadsheets on average was current and accurate. So if you think about what is happening, I mean, that's pretty scary. But it seemed real. And we had a lot of big meetings where they bring them together and try to compare them. Well, in the end, people take the information they can get and they action it. And then it iterates. And so it's almost like the way we get these things done is we go up and down and we make mistakes and we slowly work ourselves to the end. Well, assuming that problem is there, Gen AI can absolutely nail that one. And I think that especially will show during, not in the early phases as much, but as things branch out to large number of suppliers, a lot of changes, problems, in launch, quality issues, all those areas where you really just need to know what the current state is and what you need to do. I think AI is going to really help that.
Right. But who do you think will make this kind of big decision? Because connecting all the data, it involves a lot of uh, stakeholders, different departments. How do
Well,
you think
I think if I mean this is already
the
happening.
top-down approach is what generally
Oh,
works?
top down, bottom up, whatever. Well,
Mhm.
I think it should happen at both levels because top down always gets it wrong, and bottom up always gets it wrong. They get it right at their level, but and so I think what well, here's the problem I had with it. At Infosys, we go in and Infosys is a great company. We go in and say, we can change your world. We can do everything you dream of. Here's the price. And, we'll put this all together. I think there's a lot of people making big money on it, the big new AI companies like Palantir or whatever, and they'll just collect all the information they can and put it up in a big warehouse. Pretty expensive to do and maintain, but it does work.
Mhm.
Well, they kept that. I was a CIO like three times, right?
Mhm.
And so even though I've been an engineer more than a CIO, the people would say, "No, Rick, why should we pay you all this money to do this custom thing when we can just wait for SAP or Oracle or Siemens or PTC or Dassault to just put that in their products?" And of course, I had a really good answer why they shouldn't wait. But I started thinking about it and I said, well, I gave him a really good answer, but if it were me, I'd wait because, I'd work on something else. And so I
So they're
think,
not going to put it. The
yeah,
waiting time is too
well,
long.
I think you need a strategy, which
Mhm.
hopefully most people have, although I suspect most don't.
Mhm.
And you need to probably assess and talk to your vendors and see what they're going to give you when, and whatever they tell you, it's probably going to be a lot longer than that.
Mhm.
But then you need to figure out if you have that, all you really have is, the data type of stuff they maintain today. And then you ought to think about more holistically how you're going to pull that all together and maintain it. And again, I think it's going to be some kind of a private cloud that you put up on one of the big, AWS or Google or um, uh, Microsoft
Mhm.
is the big players, and maybe there's some others, and you're going to use their AI as it matures. I also I do consulting in this space, but I also have a software development company, and we work on products. And I'm still technical, so I work as before we were here. I was on Anthropic, coding away, and I do until late at night every day because it's like a dream. I've been a coder all my life as a controls engineer, and the other thing about it, though, is it's changing. Like one month it can only do so much. The next month I can almost say, hey, like Star Wars in software. Hey, computer, I have this thought. How should I develop it in detail? Okay, let's start. Go ahead and do it. And I just keep making prompts. I don't write code anymore. So we've been talking mechanical, but when you go over to the software development side, it's dramatic. I mean, people say it's 50% more effective. I think it's. I don't want to give a number, but it's game changing. And I talked to a lot of other people that are doing this, and I think it's a whole new world. Now, as you work down closer to the hardware, meaning the electronics, which is typically what automotive companies do outside of the IT group, it gets a little more complex because the right now AI doesn't necessarily have the data to understand how the electronics work. I mean, there's information you can feed in and so forth, but it becomes less efficient the closer you get to the electronic hardware. However, there are some strategies, and I think most of the companies use them to sort of isolate that complexity and build up. But that's probably the biggest effect. If in fact automotive, if we're talking automotive or
Mhm.
industrial products a little less, is if it's software is half the cost, then that world has just it's just not the same world. And uh and it's fun. I mean, it's really fun to. I think on the last launch we did, I personally made over 1,000 prompts into AI. And so The only thing I would ask that it's faster, that I don't have to wait a minute or two. But if I could just literally, if it could be responding immediately, it would be. I mean, I can't even imagine the speed level, 100 times faster or
First,
something. I don't know if everybody on the call has experienced that. I doubt it because you got to have something to do and the reason to do it. But I talked to a guy that's works on the system of one of the phone companies. They have 300 people working on their code, and they're all using. There's several ways to do it, but they're using Cursor with Anthropic, and
okay.
it's keeping them all coordinated. And they're each working on a section of code, and it's immediately available to the others. Well,
Hmm.
I mean, that seems impossible. I mean,
I
and that
understand.
only was possible starting in about December of this year when Anthropic made some change. Now, all the others will probably follow. But anyway, enough of my excitement about AI, but I'm experiencing it personally. Now, manufacturing and product development, though, in general, are my focus.
Beautiful.
And when
Why
I
do you
once put
think?
it, go
Okay,
ahead.
sorry.
When I once put in a new PLM system,
Hmm.
the mechanisms teams that do the really detailed mechanical work in a seat came back and told me that I had just reduced their efficiency by 50% because they're having to type all this information into PLM now that they didn't used to have to do. They used to just, well, like typical mechanisms in seating has about 26 parts probably, and often an engineer will work for 2 years changing those parts to just get them right and working with the vendors and the tooling people and so forth. It's a different kind of work. And now all of a sudden, if every time they do something they have to type it up there as computer, just keeping it their work, they hated it.
Right,
They
reduce their efficiency.
now, my goal would be, and hopefully with the vendors, and I'm sure they're all thinking that way, that it'll become as efficient as it would have been if they just worked on it on their bench, and the systems more or less kept track of what they're doing and kept everybody else, because they're in an extended work group or even vendors and suppliers, that would all be possible. And I guess we'll see.
Interesting. What do you think is the biggest challenge when manufacturers are trying to adopt AI? What mistakes they generally see or do?
Well, I think you need to start on something small and make sure the value is really there. And I think you need to understand there's a lot of things you can do, but a lot of the things don't necessarily have a big value. I mean, they're fun to do, and if I can replace a small part of somebody's work, that's good. But I think you want to understand the things that could really make a big difference, because uh, people are still, especially in manufacturing, skeptical of AI. And so you don't want to do an AI project that's really cool. It either doesn't work or it doesn't give a return. Then it'll slow things down. So you want to pick the ones that are going to work. Secondly, I think you have to be really careful about just trying to do it yourself. Uh, in even a couple years ago, a lot of our work was taking stuff that people had done themselves, which worked, but it did not work well enough to roll it out. In other words, you can get 80, 90% right, but if
Okay.
you need to be 100% right, that's a cool thing you did, but it's really hard to get the 80 to 90% to 100. And it takes expertise that typically is not available in most companies to get to that last level. And I've seen that 50 times. And it was really easy way to get work. Give you an example, a simple one. One company did on their own the ability to answer questions on, and this isn't even in manufacturing. Manufacturing would be more critical. Answer questions when an analyst calls in and asks about your yearly report or your monthly report. It's information that's there. Answer it, and they got it pretty good, but it wasn't good enough, and we were able to pretty quickly fix it. Same thing happened on answering HR questions, like
Okay.
when do I get my whatever, and it got it close, and they spent a lot of time on it, but then uh, the big the services companies primarily or the software vendors, they nail those things, and they're often in ways that aren't structures that aren't available for just working with tools off the market. And so I think a big mistake you can use, and I've hit this earlier, is trying to do it yourself and getting some result. But I think more you should be seeing, having somebody show you something that does work that they have already, and then making it fit into your world and then managing that like you do with everything else you do. Anyway.
I understand. So, about the workforce, there is going to be massive amount of change in the way we work. So, what do you think would be the future role of engineers, factory workers, and the product managers? What would be the role will look like? Just a check validator, or what would be the role?
Well, I think AI is going to hit. Well, so I did something when I was at Infosys one Christmas. Again, I code. And I said to myself, what are the, I asked AI, what are the six processes you have to do to design an automobile and manufacture it? And it came back with six processes. And I said, how will AI help each of those? And what's the percentage opportunity? And it came back with something I could put in a spreadsheet, right? But then I learned this years ago working with what's now Accenture. Uh, I said, okay, now take each of those six and tell me what the six sub processes are to do that. And I iterated it down six levels. Turns out to be about 4.5 million processes. And at the bottom, I told it to tell me in detail how do you do each of these processes, and tell me in detail how AI will help each of these processes, and tell me what data I would need to feed AI to be able to do what you just said I can do, and tell me what the return. And it did it. And I don't know all the processes, but I know a lot of them. And I looked at them and I thought, I never thought of that. That makes sense. Now, the value could be very small. Uh, it could be very large, but the thing that hit me was it affected everything. And then that asks the question, are we even doing it right? If everything we're doing is now being affected by AI, is our high level processes on how we go about things? I don't think so. In other words, our high level processes were developed by Henry Ford and the Skunk Works at Lockheed Martin, where they just put together a process on how you build stuff, and we've automated it. But this is radical. Now, it'll take years for this to roll out and for us to figure that out. But I think it's gonna, it's gonna affect everything, and I think the people that work in this environment will have to go whirl with it, where they will have to learn to use the tools and how to. I hate to say how to prompt because it's not just how to prompt. It's how to recognize when it's wrong and how to uh, well, one person put it to me like this. They were talking about Tesla's autonomous driving, but I think it applies to everything. They said it's like driving with a new driver. Your son that just got their license. It does work, but it has to be watched constantly. So I think the I think you'll work less worrying about how to do stuff, but you'll work more about how to recognize that maybe it's going through the stop sign and how to quickly adjust it and point it in the right direction. I think the knowledge level of it will change, and I think from now on we're going to be working with AI as an assistant in every manner we do it. And sometimes it'll work well, and sometimes it won't. But I think get on board with it. And I've had this. It's now happening more naturally, but with people that I code with, some of them ex CTOs, some of them really would resist this. I mean, just it's wrong. It gave me a wrong answer. I'm not going to do this. And I think this is going to happen to everybody if it hasn't already. And you have to ask yourself, is this you? At first he said, I'm not going to use this. And he's this engineer that actually made a whole bunch of money as a CTO of a big internet company, but I still code with him on stuff. And I talked to him a month later, And I said, "Well, I'm going to do this. I know you don't like AI, Dave." And he goes, "Oh no, no, it's the greatest thing in the world. It's you can't work without it. I use it every day." And I hate to use it like this, and I don't mean any disrespect, but I feel like I transitioned him. you
Okay.
know, and
All
I
the work is done by the
yeah,
AI.
and I think, and I probably need transitioned again. I mean, it's like I sort of have found my little place, and you heard my excitement. But I'm sure there's somebody out there that's saying, Rick, he doesn't understand. There's another transition he needs to go through. So I think all of us are going to go through multiple steps of, let's call it maturity rather than transitioning.
Okay.
And I think it's happening pretty fast. And, we'll see.
I understand. Interesting time. Where do you see that in 3 to 5 years uh, with AI in manufacturing? Where do you see like AI powered manufacturing will be?
Well, so I think there was a study that said AI is used in some fashion, in about 50% of product development today. Some Gardner maybe did it or somebody, I don't remember. In manufacturing, it's like, I don't remember, I think it's 2%. It's the laggard in everything. Now, you can argue there's some reasons for that, and we've discussed on some of them. One, there's heavy machines, they're set, the controls, things are in them. There's training of workforces. It isn't all just information management. It's hard parts management. Well, certainly in supply chain, it's heavily used already, and there are places to use it. But there's also this just like I said earlier, if it's working, don't mess with it. And I think manufacturing has to be careful. Like I think one time in my past, we put in a new system. In some manner, it screwed up the transition from engineering to manufacturing on one part number. Okay, I think it got what they do got the units wrong on a part number, and pushed it into the system. Well, the effect of that was more or less to shut a plant down for like 3 weeks because
Oh.
the automatic ordering, um, it didn't order enough. In other words, it was supposed to order, I don't know, 10,000 and it ordered 10 or something. And uh, so, I mean, that's a simple example, but little mistakes in manufacturing can have huge, huge issues in cost and, people out of work and maybe even safety issues. So I think we have to be careful in manufacturing on the one hand. On the other hand, if a manufacturer becomes fully capable in your space with these tools, and especially with the company I've been working with, I've seen it more directly. That's a factory floor. Uh, you can get sometimes 10% factory efficiency, maybe even more, by just having AI help you make everything happen more concisely and more quickly. And that's hard to, I mean, that's huge money in manufacturing. So that'll be very difficult to compete with. So I think they call it yin yang. You need to be really fast, but you need to be really careful.
Mhm.
You need to be really good at it. How's that?
Yeah, definitely. That's how the world is looking like. So one final thing, like for a manufacturing that for them, if they are watching this, that they have to think about this and do differently tomorrow with the AI and something. What would be your advice?
Well, I gave you some of it.
Hmm.
Um, I think you need to
One
understand
thing that you
three
need to mention.
three tools. Three. You need to understand what what will make a difference for your company. And we
Hmm.
didn't even talk about the information customers can glean today that they don't have access to, and how you do quoting. It can be so automated, and I've been involved in that. But if you talk pure manufacturing, you have to accept that it's going to happen. You have to get partners because you won't have the internal capability to do it. I mean, even companies that have really good AI people, they just triple their salary and leave. So you have to have partnerships with your suppliers and probably with some people at a higher level. I mean, when I say higher level, above and beyond your current supply base, some of the people that are going to give you that whole overall capability. And you have to really envision uh, how you want your plant to operate in the future,
Hmm.
fully AI enabled, and then how you're going to get there. And it has to be and you can't do it all at once. You have to pick your spots. And you have to also, I mean, the simple thing is you have to give everybody in your company access to AI in a private, secured manner, which most companies have not done. They look, well, I can't afford to pay that $20 a month to, 300 people. I mean,
Okay.
everybody should have access to company enabled AI so they become familiar with it, comfortable with it. I've said that if I were back in my old job, I would give every employee, I would have in the one-on-ones, I would work with them. And even if it's something as simple as optimize the cafeteria menu, or
Okay.
something, I would force every one of them to use AI in some manner that would help the company, and then progressively work up the scale and the size and the outside assistance that had that. So everybody as a side job is learning how to use AI as part of their work. So you have in the end, a fully AI enabled workforce, and in turn, you've picked your partners with plans to get it better, because the money you invest here right now is going to be worth more money than you invest anywhere else. Both on and also into your products. How's the market look at your products? I mean, most people get that wrong. AI can certainly help that. Anyway, that's
That's
saying,
that's great. Yeah.
wonderful new world.
Yeah.
Last thing.
Yeah.
So here's for any of you that are big time corporate people. When I was at KPMG, I was really early on in e-commerce, and I had a practice, North American practice, and we would. Uh, I was in the industrial area, so we would go in and do this strategy work with generally we were the auditor. So the auditor would say to the partner, "What's this? What's this e-commerce stuff?"
Hmm.
And so then they would call me and they'd say, well, you got to go talk to the company, and we would send in a team and they'd spend a couple weeks interviewing everybody, and we had this process that would spend a day with generally the president or CEO and his staff,
Hmm.
and because they need to report to the board what's going on, and we would go through and figure out, ask a bunch of questions the first day, and then the last half a day we'd show them their e-commerce strategy. And interestingly enough, that was either a website for their products, a website that they could sell from, or a marketplace. And we had all of those happen. But back then, they didn't know what any of those were.
Okay.
And I was younger then, probably 30 years younger. and,
Okay.
but, I was really, as I am to this, I was into that. And at every one of them, and we gave them great advice, and they probably all did it. But after every one of them, one of the more important people in the meeting that wasn't the change agent would come up to me and said, "What a waste of time. Don't you know people will never buy anything on the internet?"
Okay.
Yeah. Because he couldn't comprehend what it's going to be. This is bigger than that. And I can't comprehend it, but I think you just need to get on the path.
Yeah. Definitely, this is going to be bigger than the e-commerce wave.
Oh yeah, yeah.
Yeah, way big. But I think we are already running out of time. So
It was fun.
thanks, Rick. Thanks, Rick. Thanks for your time. I know we have a lot to cover, but I think we'll connect for another follow-up kind of
Sure, well, it's
interview.
great, and appreciate you talking to me. It was fun.
Thank you. Thanks for your time, Rick. And have a great day. Thanks,
You too. Bye
guys.
bye.
Bye.